need to open my notes, of course. Mechanics, projectiles. How many are there? Yeah, 5, okay. Alright. You can write that down, projectiles. Alright, you got that? Is this a word any of you have heard before? Yeah, you have. Yes. So what, do you know what projectiles are? What did they, what do we study? Yeah, like this. You'll see now. Sorry, you need to write that down? Projectiles? You got it? Yeah. Okay. So anyways, first we'll start with the definition of a projectile. So a projectile is an object that travels through space with only the force of gravity on it. No other forces. Now we know in real life there will be other forces on it like drag, wind, so forth. It generally, but not always, travels along a parabolic path. I don't really think you need that, but the first definition should be enough, or the first sentence. Okay, you got that? Not yet?
Not yet.
What university are you looking at? Oh, this is the IFCs, is it?
Yeah.
Oh, I thought it was something different. Funny to see pictures of old students I've forgotten about. No, don't worry, I'll forget about you guys too.
The physics exam.
Yeah.
Normally, is it like answer all questions?
There's some choices in section B. You have to answer everything from section A.
Well, they are on different topics, so all topics and which question.
Yeah, usually there's like a mechanics question, an electricity question, and so on. But we'll have a look at that nearer to the time. Okay. You got that?
Mm-hmm.
Yeah?
Yeah.
We don't need the next part. The better thing here is the picture. So this is an example of a projectile. Once the bicycle leaves the ramp, then there's only one force on the bicycle now, which is gravity. And that makes the motion this shape, which I said on the last slide was called a parabolic path.
Mm-hmm.
Okay. Now, I don't think we've talked about it in maths just yet, but we'll discover that quadratics, you remember quadratics? They have the same shape as this. Parabolic, yeah, you knew this already, yeah. So, this is a projectile. Once the bicycle has left the ground, it has no control over its motion. The only force is gravity. Now, true, there's air friction and drag and wind and so on, but we usually ignore that. It's quite small. Okay? It'll travel along a parabolic path as shown. Alright, next now. So why is Superman not a projectile?
Because it is Superman.
That's it. True, he is Superman. He travels whichever way he wants. It's not only gravity. Yeah. Okay. Now, I have to give you some points which are worth writing down about motion in 2 dimensions. So if you can first write this down and then I'll explain it. The first point is that the dimensions are independent.
Like, these are the properties.
So, yeah, almost like tips nearly, facts that are useful to know. Does anybody know or might have a guess? What's the meaning here? The dimensions are independent. By dimensions, I mean the x and the y.
They don't affect each other.
Yeah, so how does that
We don't
affect the motion, or rather, I should say, what's the consequence of that for the projectile? Any ideas?
Horizontal motion is constant.
That'll be a different point. Yeah. The dimensions are independent. Let me explain what that means. I'll give you a little picture here. So, this is the famous example. Imagine here you have a ball and you have a bullet. Okay? And at the same time, you drop the ball. It falls and hits the ground. And then you fire the bullet, and the bullet will go like this and hit the ground. Okay? Now, if you don't worry about drag or friction or anything like this, which will hit the ground first?
Same time.
It's the same. They'll hit the ground at the same time. And the reason for this is because if you look at the ball, it has an X and a Y, and you look at the bullet, it has an X and a Y. The ball at the beginning has 0 and 0. It's not travelling right or travelling up, is it, at the beginning? It's just dropped. But, oh sorry, that's the bullet. And the bullet can be fired at a very high speed, like let's say, I don't know, whatever, 250 meters per second. And this could be 0 as well. The bullet is just fired horizontally. Okay? In both cases, the vertical is 0. And in both cases, they have to vertically maybe fall 10 meters. And it actually doesn't matter what's happening horizontally. It doesn't affect how quickly it falls to the ground. That's what I mean by independent. How quickly these fall to the ground does not depend on what they're doing horizontally. That's what I mean by independent here. Yeah? You don't accept this. There's always one person who doesn't accept this.
The way you said they hit the ground at the same time.
Yep.
So the weight of the ball doesn't matter.
No. Now remember I said ignore drag. So we're not going to worry about air friction. Yeah. Yeah. In real life, of course, the drag will have an effect. I'm actually not sure which would slightly hit the ground first if we... I don't know actually. But in real life, they wouldn't be exactly the same time because of drag. I feel like maybe the ball was at the ground first.
Because when the bullet was designed, it will try.
That's what I'm thinking. It's designed to cut through the air.
Yeah.
Yeah. Whereas the ball just, yeah. Another way to think about it, which my teacher in high school told me, and I kind of like thinking about it this way. If I scroll down for a moment. Imagine you have a wall here and the ground here. And you have a projectile moving in the air. And then it goes back down. Okay. And then imagine you have a little laser horizontally and vertically. And this laser fires a dot on the ground. Let's say that's a red laser, and then let's make this one a blue laser. And puts, oh, that's not blue. Blue. And puts a dot there. And let's say it starts here. Or actually, sorry, it starts there. It's not great. Okay. Now, what would happen at this wall if you were to look at it? Well, you would see a blue dot start where? On the ground. Then what would happen to the blue dot? It will go up, 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 stop, and then back down. What would happen to the red dot? It would start here, and then move right, 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 and then it'll stop when the ball hits the ground. Okay? My point is, when we say the dimensions are independent, we can think of one projectile as two UVATS movements, one on the X and one on the Y. So we could forget about the red and only study the blue movement. Up, stop, down. Or we could forget about the blue and only study the red movement. Right, 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 right. Okay? So in other words, the formula is like this. Projectile is 2D, isn't it? 2 dimensions. And when we did our UVATS problems, it was in 1 dimension, you know, horizontal problems or maybe vertical problems. So you can say 2D equals 1D plus 1D. Do you get what I'm saying? That this 2-dimensional problem, we can think of it as a 1-dimensional problem and another 1-dimensional problem. Yeah? Yeah? Now, because students have such difficulty with this idea, and I really don't understand why, every year, such difficulty with it, I want you to make some note. You can either draw this, which I like, or you can draw this, but you need to make some kind of notes to help you with this idea, get it into your brain. Okay, so I like this idea. This is helpful for how I think about it. Yeah. So Peter, do you know what I mean when I say laser? Firstly, yeah. Okay. So there's like 2 little laser lights stuck on these. One that points down to the ground, and one that points left to the wall.
So like when it points up, one laser is going this way, like going this way, and down. And then you only see the blue laser like once it does, or you see the red laser.
Nobody has any lasers, do they? No laser pointers? Yeah, yeah. Do you have one with you?
When I was very young, I have a
Ah, we all had those when we were young. I was wondering if anyone had one now. I'll have to buy 2, maybe a red one and a blue one. Yeah? Yeah, yeah. I'm seeing you thinking deeply about this. Are you happy with it or not? Okay? Yeah? Continue? Not yet? Okay. So this question was on the exam that the September students did 2 weeks ago. It was in section A. It was something like A5. And it was the only question on the exam that everybody got wrong.
No.
No one got it right. It was a projectile question. So like I said, I don't understand it. I just don't understand it. Okay.
Because it's different from the we know in our daily life, so it's hard to maybe realize.
Yeah, well, I think it's difficult to get your mind into it. Yeah. Yeah, because I can see some people struggling with the idea. Right, continue. The next point. Gravity acts only in the y-axis. This was kind of what you were getting at earlier. Okay? There's no acceleration in the x-axis because there's no force in the x-axis.
What do you mean there's no acceleration on one axis?
So, in the x-axis, it's moving at a constant speed. There's no force in the x-axis. Gravity's only in the y-axis. So what could make an acceleration in the x? Well, there's nothing. The gravity's only in the y. Yeah?
Any car moves, they're moving from the x-axis.
Say again?
Like cars.
Yeah, but generally cars don't go like this. You know, we're only talking about projectiles.
Okay.
Vectors can be used to resolve projectiles into x and y components. So what I mean by that point is, if you have a projectile with a theta angle and a u speed, you can calculate the x and the y using sine and cos. What would this one be? Yeah, u cos theta, and this one here is u sine theta. Okay, so that's what I mean by this point. Yeah?
So if, what if there was like a force that was used to trigger an accelerator, launch the projectile?
As soon as the projectile leaves that launch point, then there's now only gravity. So I suppose what I'm saying is, it doesn't matter how the projectile began its motion. We're only studying the subsequent motion. Okay? I think I have more points though. The next point is something you already know. Projectiles have no vertical speed at their maximum height. So once it reaches the maximum height, vertically it's stopped. Okay? Got that? Okay, next. And remember, S is a position, not a distance. And the last point is worth restating. For example, a ball that's kicked along a field will have Sy equals 0 at the end of the flight. Let me show you. So I'll go back to this in a moment. But if we look at this example here, when the ball is here, for example, Sx is this, and Sy is this. But when the ball is here, Sx is this, and what's Sy? It's 0. If you look at the blue dot, remember, the blue dot goes up, stops, and then comes back down. At the end, Sy is 0. There's no height at the end, it's hit the ground. Yeah. Yeah. I'm just seeing confused, sleepy, hungry faces.
Really mistake.
Huh?
Let's mention.
Oh yeah. Okay, you got that?
Yeah.
No.
Not yet. Yeah. Continue. Okay. Continuing. Right. Let's do this one together. A projectile is fired at 30 and a speed of 100. So I'll draw that for you. Projectile is fired with 100 meters per second at an angle of 30 degrees. First things first, let's get this component and this component. So what is 100 cos 30, please? 86 point, give me one more. 6 what? Oh, okay, great. And then the other one I believe will be 50, won't it? Okay, good. A, what is the time of flight? That means how long is it in the air for? So which would be useful here? The horizontal or the vertical? Well, which should we pick first? Oh no, the vertical. The vertical. Because you know something about the end of the journey. Its height is 0. Watch. U, V, A, T, S. What's U? Vertically. Vertically, what's U? 50. Vertically. V, don't know. A, minus 9.81. T, don't know. T is what we want. S,
Yes.
we do know. What's S? 0. No displacement at the end. It'll probably turn out to be negative 50. Now, not always. For some of these questions, sometimes the ball drops below the level it began, so it wouldn't be here. Yeah. But you're right. I would suspect it is, or it should certainly be minus 50 because it's symmetric. Yeah. Okay. Are we happy with this last one? S is 0. Yeah. No height at the end. Yeah. What's wrong, Kehan? Or he was asking you a question?
He has a question about the y. The displacement is.
Ah, yeah. So look. If you look here, the S here, 0, no. Here, no. Here, no. Here, no. Here, yes.
Yes.
At the end, the S is 0. So, there's also another place the S is 0. Where? No. The S is quite big at the... Whoa. Oh dear, what have I done? There. At the beginning. The S is 0 as well. So let's have a look at the answers here. I'll use S equals U T plus a half A T squared. What's in common here? t. So I have t 50 minus 4.905t equals 0. I took out the t. Yeah? So I get two answers. Either t is 0, which makes sense because that's the answer at the beginning when s is 0, or 50 minus 4.905t equals 0. So what was the real answer? 10.19. 10.2 seconds. Now, you reject this answer. Okay, and you take this answer, 10.2 seconds. Okay. B. What is the range? Now, the meaning of the word range is this distance. That's called the range. So, do we look horizontally or vertically? Horizontally. Now, remember, horizontally there is no acceleration. So we can use the distance, speed, time triangle. Okay? So what's the distance? Do we know? No, that's what we want to know, isn't it? I'll call it R for range. What's the speed? Do we know? 86.6. And what's the time? Do we know? 10.19. Well, we should use 4 for calculations. Can I know the range? Yeah, range will be 86.6 times 10.19. So what do we get for the range? 882.45. So that's 882. Well, you said it was 4.5, didn't you? Yeah, so that's 882 meters. Yeah? Okay, and finally C, what is the maximum height? So that is now this distance. Okay? Horizontal or vertical? Vertical only. U, what's U? Vertical? 50. V, 0. A, minus 9.81. T and S, we don't know. And S is the thing we want. Yeah?
T is a half.
It should be for this situation, but not always. Well, give me the S easily. The maximum height will be the SY, the S vertical. How will I get that? V squared, yeah? V squared equals U squared plus 2AS. So the maximum height will be 2500 over 19.62. 127 meters. Yeah? For maximum height. Yeah? Why are you looking at me like that? If you have a question, what is it? Did you write these points down?
Yeah.
Projectiles have no speed at their maximum height. Yes? Yes?
I think T should always be a half
If for these types of problems, but we could do problems like this.
Oh, that's not.
So that's what I was saying, Kehan. For this type of problem, yes, but not always. Not always. Okay, so this is our first projectile example. I want you to write this down carefully. If you need, there's the question first. It's all pretty straightforward. Okay, will I go to the answer? Right. Okie dokie. Getting that, yeah? Got that? Yeah. How many of you have studied this before, projectiles? Yeah, a few of you. Yeah. Okay, a lot of you. Continue? Yeah. Yeah. I still see people writing. Okay, got that? Now, next. Let's see, I think yeah. Right. So this one here, I'll draw the picture. A girl throws a small stone inside the apartment, which is 25 meters away. She throws it at a speed of 25 and an angle of 60. And the stone leaves her hand at a height of 1. Okay, so let me draw that for you. Right, so here's the side of the building. So it starts here and goes up, and maybe it comes back down, I'm not even sure. This distance here, let me just draw it again, but maybe I'll have it just go a little bit higher. The heck is that? That is, what did I say? 25 meters. Okay, and then this here is fired at a speed of 25 as well. Okay. And the angle here is 60 degrees. And just like before, you know it has a horizontal and a vertical. Okay, this distance here at the beginning is 1 meter. So I have a question. My two questions for you is A, at what time does it hit the window? So after how many seconds? And B, I want to know what's the height. Height, as in this height here. H. Okay, these are the two things I want. Now, I'll do this one. I think it's actually a little easier than the last one because, well, I won't tell you. I'll let you try it first. See if you can do it. I'll give you a minute to try this. I want the time and the height where the window is. The first thing you should do anyways is get the horizontal and vertical.
The angle is 60 degrees.
It is, yeah.
Is that 2.5 or 25?
25.
What would be the position of the ball in this scenario?
At the end, is it?
Yes.
We actually don't know. It could be before the maximum height, after, we don't know, no idea.
So we should just neglect the position.
Well, what do you mean by neglect?
Like, find another formula to find the time.
Oh, I understand what you mean, correct, yeah. So, because you don't know the height at the end, you can't use this to get the time, correct. So maybe you want to try looking at the horizontal. Right. Will we have a look at this? You guys get it? Yeah? You got it, Ming? Yeah? Son? Now, as Bella was saying, because you don't know the height, you can't actually use the vertical to get the time. But we know this. But anyways, before we even talk about that, can someone tell me what the 25 cos 60 was?
12.5.
12.5. Okay. And the other one?
21.65.
What is it?
21.65.
Okay. If I look horizontally, I know the distance is 25. Distance, speed I know is 12.5. So the time I can know. the time will be 2 seconds, won't it? And then how can I get the height? Do I look horizontally or vertically? Vertically. U, V, A, T, S. The U, do I know? Yes, what is it? Yeah. V, no. A, minus 9.81. T, 2, S is what I want. Height, yeah. Yeah. Although I need to be careful because there's a 1 meter to think about. Say again?
You add it at the end when you find your.
In this case, well, we'll get to that in a moment.
One more question, please.
Yeah.
This pyramid you drew, please, what's the.
This is from a lesson we did earlier. It's called the distance, speed, time triangle. Well, oh yeah, the S. What would be the best way to get the S here? Yeah, U T plus a half A T squared. So what's the S here?
23.7.
Okay.
668.
Okay, 681. Okay, meters. So that's 23.7 meters. Now, what do we do about the 1 meter? Do we add it or do we subtract it?
You add it.
Very good, because the S represents the height from the x-axis, which is 1 meter above ground level. So the H is 24.7 meters. Okay?
Yeah.
Okay. You can write that down, please. Okay, you got that? Yeah? Yeah? Okay. Yes? Thelma and Louise drive their car off the side of a cliff at the end of their movie. The cliff was 400 meters high and the car was travelling at...
So
Yeah?
the question we just finished, which number is it so I can make reference?
It was just example 2. But if you want to watch the video later, you would need to look at around about the 40-minute mark. Okay. Thelma and Louise drive the car off the side of a cliff. So here is the cliff, and its height is 400 meters. And they're going at 36. So here's the car, and it's going horizontally and then splash. And here it's going at 36 meters per second. And the questions I'm looking for here, I'm looking for A, the time, to here. B, I'm looking for the range. C, I'm looking for the velocity. These are all referring to at the end, okay? And D, I'm looking for the speed. Again, all of these are referring to the end. I want to know the time here, the range to here, the velocity at here, and the speed at here. Yeah? So, again, just like the last question, I will give you a minute to try it. This is a little harder than the last one. Let's see if you can do it. It's a very common physics question, actually, in physics books. For some reason, people drive off cliffs in physics books a lot. So, you'll see this one if you have physics books, for sure. Try this one for a few minutes and see if you can do it. you sickening?
No,
No, okay. Here, do you need a tissue? You're okay?
okay.
You can take one. Yep. What's that? Down for maths?
Yeah.
On the timetable?
Yeah.
That's,
We have 1 hour math, 1 hour physics.
that's weird because my timetable said double physics.
Oh.
Right, you're saying it said 1 physics, 1 maths?
Yeah.
Today is Tuesday.
Okay. But what difference does it really make? It just means the next time there's a physics and a maths, we'll do two maths then. Well, what can I see the timetable? It seems kind of stupid to split it like this.
Yeah.
Stupid timetable.
Indeed.
You know.
One, two, three,
The time the initial this.
4, 5,
There's no video or
6. Maths. Oh, that's so weird. All right, Dammy, this is your phone, isn't it?
No. Teacher.
I think then I was hoping that later in the week we had a maths physics, but it turns out that's the only time it happens. So I'll just make tomorrow's class. I see we have a double physics. We'll just do a maths physics then tomorrow. Seems strange, but okay, whatever. I would have preferred to have kept the subjects together. Oh well. Whose is this? That's yours. Right, do you have this finished?
Nope.
No.
Not yet.
Not yet. Do you think you can get it?
Yeah.
So maybe 400 is equals to half of 9.8. Yeah, okay. Is this a standard formula or you drive it? Did you drive it?
Study before or
Like, did you like come up with it from a diagram or it's a standard formula? Like this, your drawing.
Yes, I tried.
Yeah, did you look at your drawing and come up with this?
Yes, I look at it and try to do this.
All right, have you got it now?
Yeah. Wait a second.
Okay.
Sorry, if
Yeah.
for the range,
Yeah. Okay, I think there should be enough time. Let's begin. So, part A. Should I look horizontally or vertically? Vertically. U, 0. V, don't know. A, we do know, minus 9.81. T, don't know. S, minus 400.
So actually it's two.
No, that's safer. Well, you
can use
could.
positive.
Yeah, you could, but
So
I don't want to.
Positive.
Yeah?
minus
Yeah.
cancel minus.
Yeah. I'm going to keep it like this though. S equals ut plus a half a t squared k hong. Is that English? English only. So what's the t?
Teacher, I don't use the math number.
That's
Nine.
fine.
9.03.
Seconds.
Yeah.
Okay, B, what's the range? So we can use the distance, speed, time triangle. Distance we want. Speed is 36 and the time is 9.03. So what's the range?
325.097.
Okay, we'll just
Oh, yes.
325.1 meters, yeah. C, what's the velocity? Now here I want the velocity, so I need to find both the Vx and the Vy. Now I know what the Vx will be. It'll have to be 36.
Yeah.
No. Well, just before it hits the water. And the Vy?
Vy is GT.
Yeah, it'll be U plus a T.
Yeah.
And what's that?
88.
88 point.
88.58. 59.
5, 9. Okay, so roughly. So what I can say is at the end, it's going horizontally with 36 and vertically with 88.6, roughly.
Yeah.
That's the velocity.
We have to find the angle.
10.
Yeah, it's okay. You have a choice. So if I said what's the velocity, you can give me the horizontal and the vertical, or you can give me the magnitude and direction. But for the last part D, we need the speed, which is this here. So the speed will equal square root 36 squared plus 88.6 squared, which equals
95.63.
Now, I know I didn't ask for it, but sometimes in the exam they do ask for this, the angle. So let's calculate it. What's the angle here? I'll need to get tan inverse 88.6 over 36. Right, so what is it?
67.88.
67.88?
Yes.
So 67.9 degrees downward. Oh, and let me ask you one more easy, sneaky question. F, what is the maximum height? 400, okay, good. All right. Yeah, it's just being
And it's
silly.
okay.
And what?
No.
Anything is... Yeah, okay.
Sorry, so the distance can be both horizontal and vertical?
Yeah. Question?
But then
Oh.
I'm kind of confused towards the sign when it's positive and when it's negative.
You actually have a choice. You have a choice. You can use it. What I did was I said right is positive and down is negative. Whereas some of the students here said right is positive and down is positive. It's actually your choice. As long as you're consistent throughout the question. Do you know what I mean? As long as you all... So which one would you prefer? This one or this one? What?
Down is positive.
Yeah, that's fine. So that's how those guys did it. You just need to make sure every time you're talking about downward you have to use positive. Yeah? Question now, yeah?
But then for gravity...
Oh, one sec, sorry, yeah? This angle? Tan inverse 88.6 over 36?
At the end.
Oh, in the picture here, where would it be? Yeah, so it hits the water like this. So it'd be this angle here. Yeah. Okay, Bella, what are you saying?
Well, concerning gravity,
Yeah, your choice. Do you want it to be a minus or a plus?
same thing.
Yeah.
Like when it's really
All that matters is that you're consistent. Okay, did you write that down if you need to? Yeah? Yeah? Okay, okay. So, if I go back here, let me have a look here. Now, guys. There are 5 projectile questions. Because projectiles is quite difficult topic, I don't want to start a new topic today. So I want you to use the 20 minutes that's left. Try and get those 5 questions done now. Okay?
Oh, no.
Yeah. Now, of course, if you don't finish them, you have to finish them at home.
No.
But, you know,
I'll finish it.
if it takes you 4 minutes per question, you could get them all done now.
then I can.
Yeah, did you not get the web address I gave you?
Yeah.
Yeah?
But I don't have Wi-Fi everywhere, and I just.
Oh, there's Wi-Fi in this room. I'll have to write the password down for you.
Yeah. I got my SIM.
Oh, good. Who did you go with?
Wi-Fi.
No, there is Wi-Fi in this room.